So it will come to rest at C. It's asking work done by the friction. In between, let's see that what is the state. So let this be the theta. D is R by 2, no? We know it. So let this be the small r. Let this be X. How the gravitational force will act here? The gravitational force will act in this direction. Don't put mg here. The gravitational force will act in this direction. Then how the normal contact between the normal contact here will be in this direction. So definitely the friction will act in this direction. And here it will have some velocity. And finally it come to rest. It is released from rest and it come to rest. Okay, I think this much of data is what we should be ready. Okay, let's get into now. Let's get into calculate the work done by the friction. So let me do one thing. Let me this is O, A. Let this be B. Potential at A, potential at B first we'll calculate. Because it has moved from rest to rest, no? So therefore, the friction does negative work. The friction does negative work. Altogether from A to B, it has moved from rest to rest. Then friction does negative work. So therefore, there should be decrease in gravitational potential. The decrease in gravitational potential G got converted into, it is utilized to overcome the work done by the friction. That's the core idea. So what is the potential at point A? We'll calculate. Potential at point A should be equal to minus G m naught by R. Potential at B. Potential inside should be equal to G m naught R square. I think the formula, let me recollect. 3 by 2 R minus
square.
Okay, I think this much is our formula.
Sir.
Negative sign I'll bring outside. Huh? Put smaller equal to 0. Potential at the center should be 1.5 times. Remember either of way, it's left to you. Okay, let's calculate potential at B. So what is the value of, I think I'll write some other thing. Yeah, smaller will become here. Some S I'll write it, no problem. What is value at B? What is value? R equal to D by 2. That itself is given. R equal to D is equal to R by 2. Yeah, anybody potential at B?
Minus 11 by GM.
11 by 8 GM naught by R. No. How to calculate work done by friction? So you do one thing. So when it moves from A to B, what is work done by the gravitational force? It does positive work, no? When it does positive work, potential G must decrease because the conservative force. The decrease in potential G is utilized to overcome the work done. So therefore, I'll go for work energy theorem. Of course, I can apply conservation of mechanical energy. If you want, I'll write it in terms of that one. UA. Better we'll write in terms of this. Ka plus work done by the gravity. Work done by the friction equal to Kb. It is released from rest. Work done by the gravity. Mass of the particle m into Va minus Vb. Work done by friction. Friction does negative work. Look at this. So now substitute this m into potential at A minus G m naught by R minus of minus 11 gm naught by 8r. This should be equal to work done by friction. Minus 8 plus 3g check it. Okay, here what happened? You do one thing, put positive only. I took negative. Okay, better put positive. So we'll end up with negative sign. Or else, since I know work done, friction does negative work, you can introduce sign and you'll get the magnitude. You want to check, is it positive or negative? Don't put any sign because we don't know anything. Then we'll get negative. So it does negative work. Okay, this is about part A. Is asking to get the mu. How to bring mu? So we know work done by friction. We know work done by friction. So let's calculate the normal contact. So what is the normal contact? Normal contact should be equal to F cos theta. What is F should be equal to? G m naught m by r cube into S into cos theta. Keep it here. What is cos theta will be d by S. S get cancelled. So G m naught m r cube d is r by 2. This is the expression for normal contact. Then work done by friction. So as it moves from A to B, what is the displacement? So I'll write it here. Work done by friction should be equal to mu F into AB. So what is F? F should be equal to mu N. AB distance we have to calculate. AB will be
root
3
3
by 2.
how much?
Root 3 r by 2.
Root 3 r by 2. So we know work done by friction 3g m naught m by 8r. Mu N is g m naught m by 2r square root 3 r by 2. Solving this will get mu.
Root 3 by 2.
Root 3 by 2. See, just you have to fight with the question. Have draw diagram and what all the best things you know. So especially questions come from gravitation. No? I think to some extent, if you're not a mass oriented, definitely you can manage very well. If you're not a mass oriented, if some integration based somewhere here and there, maybe due to not taking suitable limits and will end up. If not a mass oriented, you can very easily comfortably manage an exam. You look at that why the advanced questions, no, almost students are very comfortable final exams gravitation because the questions will revolve around momentum, conservation of angular momentum, conservation of linear momentum, then center of mass, or say like a conservation